Initializing containers. C++, abstraction mechanisms. A container exists to hold elements, so obviously we need convenient ways of getting elements into a container. We can handle that by creating a vector with an appropriate number of elements and then assigning to them, but typically other ways are more elegant. Here, I just mentioned two favorites. Initializer list constructor. Initialize with a list of elements. Push back, add a new element at the end, at the back of, the sequence. These can be declared like this. Class vector. Public. Vector, std, initializer list, initialize with a list. Void pushback, double, add element at end increasing the size by 1. The pushback is useful for input of arbitrary numbers of elements. For example, vector read, isstream address of is. Vector v. For, double d, is the d, read floating point values into d. v.pushback, d, add d to v. Return v. The input loop is terminated by an end of file or a formatting error. Until that happens, each number read is added to the vector so that at the end, v's size is the number of elements read. I used a for statement rather than the more conventional while statement to keep the scope of d limited to the loop. The implementation of pushback is discussed in the way to provide vector with a move constructor, so that returning a potentially huge amount of data from read is cheap, is explained in the std, initializer list used to define the initializer list constructor is a standard library type known to the compiler. When we use an array list, such as array of 1, 2, 3, 4, the compiler will create an object of type initializer list to give to the program. So, we can write vector v1 equals array of 1, 2, 3, 4, 5, v1 has 5 elements. Vector v2 equals array of 1.23, 3.45, 6.7, 8, v2 has 4 elements. Vector's initializer list constructor might be defined like this. Vector, std, initializer list lst, initialize with a list. Elem, a new double, lst.size, sc, lst.size. Copy, lst.begin, lst.end, elem, copy from lst into elem. Thank you for watching.